Alright, so this is part 2 of the IT-03 end trimmer station repair on the Biesse 1300 series machine. We have gone in and ordered some parts from a third party, brought those in, just a couple bearings, nothing too spectacular. The customer has those in stock now, and they have made room in their schedule for me to be able to have access to the machine. So what we're going to do in this one is we're going to go in, disassemble the station again for the second time, and go in and fully diagnose everything to make sure we get all the parts replaced, and also diagnose the underlying cause, which we believe to be that the trimmer itself is actuating too fast. So when it cuts and then returns home and then cuts and returns home, we believe that speed that it's traveling is much too fast. So we're going to go into what we believe is the cause for that, and then get the underlying cause for this entire service call to get it resolved. So let's jump into it. Alright, let's get our dust hoses out of the way. Make some room in here for this. Disconnect our motor. That down out of the way. I think I can do this without blocking you guys completely. Now these hoses were marked prior to my arrival on the first visit. So get those pulled back and out of the way. For some reason, that nut there is missing. So we'll have to go out into the warehouse. Fine. Come on. Why is that so tight? Good night. The thing doesn't need to be that tight. Alright, just like that, the trimmer's out. Alright, so I drop that nut. There it is. This nut here. Alright, so there's a pair of jams on the top of it that I neglected to take loose. Because, you know, the way it goes. Now what I need is on the top of this. See if I can get you where you can see. Let me try the other camera. Up in here is a captive nut. It's a spanner. The ones with the two little teeth on it. We need to get that loose. So let me grab the new one. Wherever I put it at, it's in the sleeve. And we'll get that taken loose. Alright, so we got the new spanner wrench. Needed one of these for years. I've just always made do. What this bad boy does, different pins on the ends. Change the pins out based on what it is you're going to be adjusting. The trick is to find the right pin. I'm not sure what size hole that is up in there. Fits. It's too big. Alright, so for those of you who have never seen one of these, this is an adjustable spanner. Side post. You can see that? See those pins there? You choose the pins based on what the nut is. And then you adjust the forks to maintain position, depending on what the gap is. Got a little knurled knob here, change that spacing. So all we gotta do is get up in here where we can see it. That is easier said than done. Easier said than done on this because they build these components on a bench. You don't plan on you taking them apart out in the field. Alright, so I need to stop where we're at because I need to get a light. I can't see up in here adequately enough to make this efficient. Let me go grab a different light. Utter nonsense. Alright. You see that spanner there? You see that? I'm not sure how good it's going to show up on camera. Try it now. You see those? So I get the frequency of the LED. Absolute stupidity. So, those pins that you see there engages. Now what we need to do is take that battery or that bearing out, not battery, bearing. See which one's bad. Where is it bad at? Get something to tap that back down. Alright, so it's going to be noisy in here for a little bit. They've got the forklift overrun behind it. He's oblivious to knowing that I am videoing. It's not unusual at all. Take that out. So I'm not sure which bearing is loose, but I'm going to guess, since I have a heavy concentration of grease around the outside of this one, grease and debris. My problem is that this bearing was either loose on the hub see if you can see that, how much is on there. Everything was seated in there correctly. See that? This is a dry system. Now let's see. I'm trying not to touch the camera with my... That bearing's bad. It's down here. Oh yeah. That bearing is very bad. Alright, I need to run out, Get my hands clean. Get this stuff switched out. Alright, so I found the source of our problems and our variations. I'll see if I can get the camera in here in a minute. Holy cow. Things are starting to make sense. Get in here with the other camera because it's easier to maneuver around. It's a little smaller. Down inside there, inside that ring. If I can get this where I can hold it at the same time. Down inside that ring in there. And you see the gray lines, multiple color lines that's in here. That those dark rings you see is where the station was slamming around, slamming so fast when it's moving back and forth. It's going back and forth like this, and it's just slamming in there and eating the inside of that housing up. One thing about these chemicals that we go to put them in is that they don't like greases. So we want to make sure that we don't have any grease. I'm going to put this on my finger. Typically I wouldn't. I would put it directly on the metal. Oh, bugger, got it in my threads. Alright, so we have to stop here because I got it. We have some threads at the top of that housing and I just drenched it. Alright, because you know, sometimes it happens. Now the reason I'm going to stop, clean it out, is just a little bitty bit of that sleeve retainer will lock those threads in place and it will never come out. When I say never, I do mean never. We'd have to get it, take it off the machine, heat it up, do it with a torch, get it several hundred degrees. 5, 6, 700, depends on what the product is. Nonetheless, that would be a bad day. Alright, now we'll give that thing a few minutes to dry out. Yeah, that groove that's in there, I can feel that with my fingers. I can see it and I can feel it. Doesn't take much. Depending on what your gap is. This is only a few thousandths that I can tell. If I really cared, I could put an inside gauge in there, but it really doesn't matter. Just going to drop these bearings down in there. Now, I'd mentioned to you, making sure that you can see the bearing number after the fact. I know I can see it with this. Look for it. I had looked for it before I put the bearings in. Just like that. Nice and easy. Back to the back. Alright. I went out and got some hand cleaner, some wipe off towels. Inside of this housing and everything cleaned up. Those bearings, new bearings out. Everything straightened up. This thing in here has just got just one of those spots, you know.
So now we got that cleaned up. I'm gonna get the new bearings out, get the shaft cleaned up on the motor over there. We're going to do something different. 11.2. Get this thing off in our hands. For those of you asking why I'm in such a hurry to get this done, is once we put that chemical on there, we're racing the clock. Let's see if we can get this thing off in our hands. I'm not real big on pulling this rail off. We have a lineal bearing there. We take it off, we have to be careful we don't lose any of the bearings. So you see this rail I'm taking out here? This is what we gotta be so careful of. When we go slide this back in, we can make sure that this rail goes in straight. Now I got this off. You see how it's cross-threading? So we're gonna get this off on a bench where we can do it by hand. Alright, we got this out here where we can see. Let me see if I can get the light around where everything works well. Got good focus on that? I think so. No reason that we're fighting with this thing that hard. This nylon jam down inside. You see that nylon that's in there? That little bushing? That presses up on these threads. That's only part of my problem. The problem right this second is this cross-threading, just trying to get it to start. Alright, so inspecting my threads. Somewhere in here I have a boogered up thread and I don't know where it's at. Threading a lot easier than this. There, finally. A little tap that I did. I was trying to bind up on it. Do a little tap on it to try to force it back against the thread. Past that lip. So the amount of force that I was taking to put all this in here, I was concerned that I might damage the lineal bearing, which was what inside my head was my final call. Yank this out because this bearing on that rail right there, you know, it's not something you're supposed to be torquing against. They're strong, but they're not invincible. Alright, sorry about the interruption. The supervisor / operator in this area wasn't aware that I was making videos and wanted to have a conversation, so we stopped for a moment. We'll take care of that. Not a problem, he just wasn't aware. This, go this way, down here. I'm going to go ahead and assemble this off the machine. I'm going to fight with it, I might as well make it easier. That lifted up, this moves around. Do need to stop here in just a moment because I've got to go out to the truck to get some more supplies. This spring, there's a spring, it's here, help maintain the position. I can get that in there, make sure. It's hard keeping all this stuff in here. I don't have a screen that faces forward and stays on at the same time. So it is what it is. But nonetheless, on these springs that they have in here, little return springs, they are using zip ties to create a barrier to keep that from creeping out. So I've got some out in the truck and at the same time I've got some nuts that I need to get out there. Put that on. I can put this on before I head out that way. Check for tolerances. Oh yeah, that baby's much tighter now. Get in here where we can put some load on it. Oh yeah, much better. Before, there were the play that I was telling you about in there. There was so much play in it, you could feel it. Probably, I'm going to guess somewhere in the area of 5 thousandths, 0.1, maybe 0.2, so 4 to 8 thousandths, something like that. Well, I've got this off of here. I want to show you this saw blade. Let me get you down here where you can see it. Hit the button. See on the saw blade here, this is another problem I have with this design. Most of them aren't like this. Most of the single end trims. But you see this long rake tooth that's right here? You see that? When they shift this from zero to bevel, back to bevel, it only plunges straight in and straight out. So the way that they do their beveling on their thin material is they use this long rake tooth, and it actually kind of grinds sideways across of it, eats it up sideways. Traditionally, whichever direction it points, it swings in relationship to that angle, whatever that is. That's the way all flying saws work. That's the way most of your single end trims work, all the way up until I seen this little. So before you go out and call your tooling guy and try to find this blade, it's easiest just go back to Biesse, because whoever it is that manufactures these, I've called Gudo, for instance, and Gudo doesn't have it. Lights doesn't have it. By the time you get it made, it's more expensive. All right, so I need to shut the camera off. I got to make a parts run out to the truck. I got to get a nut for this. I got to get wire ties, zip ties. It seems like there's something else. I don't know what it is yet, but it'll pop up in my head once I get out there. So, pick me up some jam nuts. The overall machine. Sorry to have disappeared on you like that. These jam nuts. To keep this system in line. And as always, put it together, take it apart. Put it together, take it apart. They have a guide. They have a guide here. Around here where you can see it. See this guide? This guide right here. That guide has to go around this. For you to assemble all the station, get it in there, it's just a pain in the ass. So these two flathead screws that's here. You get this around here. Sorry if I keep blocking the camera. I'm trying to get this where I can see, and it's harder than it looks. I need a dedicated camera guy, but y'all, I don't get any money from YouTube, so until y'all start subscribing and everything where I can start making some money, I don't get no camera people. So I got to crack these loose. Once I get this loose, I'll get this resituated on here. I did this the last time too. It's easier this time because we're off the machine. Let me get that cracked off, lined up, get you back up here where you are in a perch. You see it from 30,000 feet. Got that off the way. I need some Loctite glue. Alright, so a lot of times, you know, we like our Loctites. But you see in my videos, and I know I've said this over and over and over for those of you that see more than one, I used a Loctite product that's in the lipstick tubes. And it's a little bit more expensive, but for me it's cost justified because when I fly, the TSA doesn't open it up and inspect it and forget to put it back. I have an appreciation for what they do, although I think they're perfectly, or I think the TSA itself is useless, but they do have a tough job, and when they open up some of these chemicals, they don't know what they are. A lot of them, well, let's face it, if they had a clue what a lot of this stuff was, they wouldn't be working a government job. So when they get some of these tubes, get the tubes like that, and they don't realize, one, how expensive it is, two, it's not everywhere that I am, and then they throw it back in my box and they don't secure it where I had it at. The next thing you know, it winds up getting smashed out in my box, and then I'm out in the field without the supplies that I need. So that's the reason I carry the lipsticks. I have that in the red, the blue, both types of common anti-seize, the copper and the silver. I think it's zinc, I'm not sure. And then I also have one that is Teflon, which is for, instead of Teflon tape, I just knocked something off of my feet. What did I hit? My spring. The next item I'm going to put on. Now, spring goes here, this, and then this is their spring retainer. They're just using a zip tie. Simple but effective. That's it for here. Now we're ready to go back over there and get it mounted. Alright. So before I go putting the motor back in here, for those of you that aren't familiar with lineal bearings, see these rollers right here? There's 4 of them. When you have a square rail, this is common to have 4. And what we have is one here, one here, one here, one here. It's in the different quadrants on the rail, so that it keeps the unit from twisting. And you can see this one's a double length bearing because of how long it is. So what happens in these is that these bearings will roll to the end of the chase and then come back, and it's got to return. It comes back up into it, comes up to here, and just goes around and around and around and around and around until it's done. And then there's one of those for each of the components. They're hidden up in here. So what happens is when you go to put these in here, just go to slide the component back in. You have to be very careful when you're trying to introduce it, because these returns they have at each end of it, the bearing sometimes doesn't want to make that change in direction. When it does, it gets in a bind. If you get a bind back here, then these bearings at this point will start to pop out, and it's very easy to do. So a couple things that I need to do in this is I need to clean this up, because this thing in here is just an awful mess. Horrible mess, because this grease line is actually supposed to be supplying this was loose, and it's just getting everywhere. So the very first thing I need to do, get in here, get this all cleaned up, then we'll get that rail put back in place. Alright, so I think I've got everything cleaned up well enough. Everything here out of the way. We're ready to put this thing back in place. Slowly but surely. We're getting there. Now, all this grease and everything that I've got around here where I've been cleaning this stuff up and I've been blowing things around, we don't want that landing on top of the track, on top of your chain pads there, because it will contaminate the surface. So what I had done is I went outside the machine, and I marked the area that I'm working at here so I can raise this beam up afterwards, go in and clean all that off, because I want to make sure it doesn't contaminate my customer's panel stock. Alright, so at this point I'm going to grab my trimmer. We'll get her landed in place. Very carefully here. So I was telling you about the bearings and popping the bearings out. When that happens, you slide these in, it should be nice and smooth. If you are pushing and it comes up against a bind, then you want to stop. Alright, so I got my finger on the back side of the rail here. I can feel it. It came out the back with no issues. That is actually quite surprising. I was expecting a bigger fight than that. I guess that with all the other Barbara Streisands that we got going on with that station, they decided to give me a break. Second, I'm going to go over and grab my other wrenches and get my Loctite what I've got now is I got to remount this bracket here. That's the outside mount for this return spring. A little Dabadooya Loctite on there, each side. Come on. And there we go. And up there. One of those spots where I would like to be able to use my left hand a little bit more, but it's got some injuries from when I was a kid. I was in my early 20s. Yes, early 20s, you're a kid. So nonetheless, the dexterity is not there. Snug down, we get this one snug down. This is on snug. Snug. Now we can go in and tighten it. As I find my persuader. This will persuade it. Goes on there. We got my little keeper. Put a little dab of cleaner on the keeper. So this little keeper that I'm putting on right now serves the same purpose as that zip tie to keep my spring from coming off when it's not under load.
Let's check this now. Oh, yeah, that trimmer's much tighter. Sweet. Much tighter. Now, what's the next step here? Let me think. Think. I think I go ahead and put this on. Good for now. Let me go check my parts list and see what pieces are laying over here that I've forgotten I'd taken off. Like this one, for instance. This one goes in here. Years ago, somebody asked me, you take all these parts off, how do you keep track of them? And I said, I set them down in the order I take them off. I said, how do you remember if you put them all back on? I said, I don't have any parts left over. He says, what do you do if you have parts left over? I don't know. Generally speaking, you have to take everything apart because that part that you have left over you forgot about an hour ago. I know you guys know what I'm talking about. hose 4, air hose 3, air hose 2, air hose 1. Alright, we're almost together. We'll put this little bracket on. Oh, my light's telling me it's almost empty. Imagine that. Batteries don't last. You know what we should do? We should take all these rechargeable batteries that doesn't work, throw them inside of a car. That's what we should do. What do you think? Think that's a good idea?
review for parts. Alright, I'm going to stop the camera. This is moving better. I think I'm at a point where I'm ready to put my hose back on and hook my electrical up. Let you know the way Biesse wires these here. They use a continuity circuit, goes through the motor, looks for the thermal overload inside the motor in case the motor gets hot, or if it's one of those stations where you can actually disconnect the motor to be able to service tooling, stuff like that. If you pull that connector off, it faults the drive, and the drive that it faults, depending on which drive in the machine, sets it up for a catastrophic fault, meaning that you have to recycle power to the machine to clear the fault. And that exists in that manner for a multitude of reasons. And I'm not going to say that I necessarily agree with all of them, but it all has to do with safety. And we can't argue with safety because at the end of the day it works. And it's a good solution for what they're wanting to achieve. Alright, so I'm going to get all this stuff all cleaned up. Get all these markers off of here. Double check for all my parts to make sure I don't have anything sitting on the table. Come on, get out of there. Then go from there. So get that marker off. Again. Let's see if we can pick this up where we left off. Now, what we're going to be doing is we're going to be investigating this shuttle valve right here, because I think, by the way it acts anyway, that this shuttle valve is installed in reverse. And I won't know until I get this thing opened up. Take a look at everything, see how it's all plumbed out. So that one goes there. That's the way it acts to me. What I need to do, this is always tight in here where you got all these QF fittings, so I need to get in there and gain some access to it. I'm going to pull the prints here real quick, take a look at it. I got them here on the computer. I want to pull these and see if they're physically working. Sounds like it's working. Ooh. So, I'm not sure if it is or not. Because when I blow into this tube, it should be shuttling the valve over and exhausting here, and it's not. Alright, so I'm going to get this thing opened up. Take a look at it there. Stop this. Alright, so we got the station all back together. The pressures here on our regulators. We'll get you up there where you can see that. The pressures here on the regulators are better. So what I did was take off this. There is a shuttle valve. Let me get you. See where that magnet there gets up here. Sorry. New magnetic base, and it's pretty daggone strong. See this little shuttle valve right here. Inside of this was the debris. So when it was trying to move left and right, this could not exhaust past. and allow the air to go through there. So when this is being told to send pressure from the cylinder, from the exhaust of the stroke, down here, yeah, you see that cylinder is there? I can't see the other end of it from where we're at. So when it's exhausting, it comes up through this valve and settles its way back and forth through here. One option is it would go through this, which it does not need, or go through these, and if it goes through here, then it comes up to this valve that's up here, and on some of the machines, you will find it is up here. Other ones, you'll find them mounted back here. But on the side, what you'll see is an indicator here for the panel size. So if it's less than 250 millimeters, it wants to, let me make sure I'm saying that right. Yes, less than 250 millimeters, you want it to move back faster so it catches the end of the panel. If it's greater than 250 millimeters, you have the second flow regulator that's here, the exhaust, that slows it down just so that you, it's more gentle on the overall system. But when you're running like the ends of your door fronts and things of that nature, you want to get back to make sure you can catch it, so they speed it up. So this is the way that they do it. This is controlled actually by the length of part that it's counting from here. So like everything else, the countdown points matter. All right, then I believe that functioned because it was not coming through this valve. It wasn't going up to here because of this. It was all being exhausted through here. All coming through here. Since this was open, wide open, then it's just slamming. So I believe, some videos when I started of this, how quick it was moving. Let me trigger it, and you'll see it now. There you go. Now, since there's no panel in it, it won't cycle on the first, but it chases the back of the panel and comes back. That is much, much slower than it was before. So we are ready to get with the owner, find us some sample panels. Now that I've got all this rebuilt and this is all nice and tight, now we can go in and tune this station. Before we couldn't tune the end cut because this movement was not secure.
Alright, that concludes the service of the Biesse 1300 series end trimmer. If you found this information informative, please like, subscribe, comment, share. And as always guys, be safe out there and let's go make a million.